Thanks very much, everybody, and thank you for the Landing for inviting us to exhibit and also to talk. Those of you who've had the panel this morning may know a little bit about Holovis from our creative director Pete, who gave an excellent description of it, but I shall try and do an equally good job. So we're an experiential design company, and we use the best of breed technology to create really engaging and effective technological solutions in enterprise, entertainment and defence. So, okay, what does that actually mean? Well, that means we take technologies like VR, MR and VR, we take app design, software, art, the audio design, all of these complementary technologies and skill sets, and pull all of those together into an integrated solution. Now, what I want to talk to you about today, hopefully be pretty interesting, is around how experiential design meets big data analytics. Now, a bit of a spoiler alert, I won't be talking about GDPR, so I'm sure you're all really disappointed about that. Yeah, a round of applause, thank you. So, yeah, if you want your GDPR content, you're going to have to go elsewhere. What I do want to talk about is how these two worlds of technology or technological themes have kind of developed over the last couple of years, how those two things can complement each other, and then a little bit about how Holovis are addressing some of these challenges and trying to drive some value out of the two technologies. So we are all aware of this. The digital transformation is here. It's accelerating, and more of our lives, whether it's through work, how we have our leisure time, everything we do is becoming more and more digitised. If you look sort of 5-10 years ago, most of our sort of leisure life has been digitised, whether it's from looking at music, listening to music, or finding a place to stay, talking to our friends. All of these things have kind of changed and become digitised. Now that's great, and that gets us a lot of interesting services. But what that also does is it means that those interactions and that data is being captured. If that data is being captured, that means it can be used for good purposes, for commercial purposes, and as we know, over the last couple of years, for bad purposes as well, arguably. So that kind of revolution is ongoing, and it's progressing, and we're finding new and interesting technologies, whether it's machine learning or big data analytics, etc. Also, what's happening, which you guys are more than aware of, is some of these VR technologies are coming of age. So the form factors are coming down, the costs are coming down, the technology is becoming more robust. We've gone from the kind of the $500,000 cost for VR cave down to something more achievable. And the same thing's happening in big data. So some of the technologies that only a Deep Blue or a IBM or something like this can create. Now you can go onto the internet and find an open source piece of code which does the same thing on a GPU or a commodity piece of hardware. So this is leading to this Cambrian explosion of software, of technology, and of companies and opportunities. And bringing these emerging technologies together, in my view, always creates innovation. If you take differing disciplines with different ways of looking at problems and solving problems and bring them together into that kind of environment, that you get a really interesting and innovative solution out of that. So as I say, there's been this Cambrian explosion, and we've got a very complicated tech ecosystem. It's very complicated. It's hard to read, let alone understand. Right, so that's a measure of where we are. And the guys previous to me who've talked in the panels have talked about, is there going to be consolidation? Is it a good thing we're very fragmented? I think yes, it is a good thing. It's also a bad thing in some ways because it allows or raises barriers to entry, as many as it drops, particularly for corporates or non-technical guys who haven't got the time or the inclination to understand a lot of this. But it's also an opportunity for companies like us and for companies that you guys are involved with. What's interesting about this as well is that you have got a open source mentality, a community mentality, again, which is going to create lots of innovation and new business models like the freemium model or the open source and then you pay if you're successful model. But there is a lot of hype and there's a lot of snake oil out there. And a part of that's around taxonomy. So I'm hopefully going to try and address kind of 4 commonly used names or taxonomies which perhaps aren't necessarily clear. First up, data science. Data science isn't statisticians 2.0, it's more than that. It's the bringing together of lots of different disciplines, primarily around maths and statistics, particularly probabilistic statistics, easy for me to say, and computer science. So it's bringing the powers of distributed computing and the powers of statistical techniques together. Big data. Big data started in 2006, arguably. That term started to come about. So big data then, in 2006, if you can remember that far back, is very different to what big data is today. We're making in days, in terms of data volume, what we used to make in the entire history of mankind up to 2006. So, big is a relative term, is what I'm getting at. AI, artificial intelligence, obviously, or some other names I'm sure we could come up with that. Generalised AI isn't here. General AI, intelligent machines aren't here. What is starting to appear is expert systems and narrow AI. So very particular things we would consider as intelligent actions are being picked up. Now, if I said, well, intelligent action is being able to count or be able to do arithmetic or calculus, today I would say that's ridiculous because machines can do that. But 20, 30, 40 years ago and before, that would be considered intelligence, artificial intelligence. So it's a relative term and it's a misused term. Machine learning, again, it's a term which is kind of overused. The best description I've really heard of it is, imagine machine learning as programming with data. So normally you say, I want to solve a problem. I'm going to go back to first principles. I'm going to use logic and I'm going to build some software which answers that problem. But there are certain problems like translation or computer vision which don't really fit very well into that. In fact, it's virtually impossible to create a program like that. So what machine learning does is it takes that idea, and inspired by nature really, it takes that idea and what you create is a program which can learn by passing it data. And you pass it the data. So it's these simple considerations that, when you're looking at developing these technologies, which you kind of need to absolutely have as part of your arsenal. So the other things we're looking at is developing a data platform and an architecture which can support this. Having a modelling and a data science environment which you can create as a playground or sandbox where you can take the data and do interesting things with it. And then you've got a way of visualising it. And we're building this stack, building this ecosystem, using the best in practice so we can get that full stack that we can offer in addition to our traditional technologies. So what does that mean? Well, we're looking at functional analytics and insights. So machine learning that does Face ID, for example, would be functional. Insight would be like a recommendation engine. And we're applying this to our three sectors: entertainment, enterprise, and defence. The kind of the headlines, because I'm running out of time. Computer vision and AI game characters and narratives. So adaptive, non-linear experiences in VR and AR, and other technologies as well. In enterprise, it's advanced sensing, virtual manufacturing, and digital twin. So a lot of the work we're doing around making sure that QA is right, that machines are working in the correct way, that we're reducing the cost of manufacture. And finally, defence, and to some extent in kind of the medical area, this idea of taking neurophysiological data, ensemble data sensors, bring it all together, and then being able to understand things like cognitive load, stress, physiological responses to VR environments. So a lot to take in. I think the key thing I'd say to take away from this is there's a huge opportunity, and we're kind of looking at how we're going to attack this, but there is a merging of these two technologies, and one's going to feed the other and create new opportunities as this continues to evolve. Okay, thank you.